like I said, kind of a stepping stone into 7.4. And 7.4 has some of what I think are the longest problems in this class. So we've got to know how to do 7.3 so we can get ourselves into 7.4 on Friday. So what we're going to be doing now is adding and subtracting rational expressions. So you already saw there was quite a bit of work with multiplying and dividing. There's a little bit more work with adding and subtracting. So first we're going to go back to some basic examples of adding and subtracting fractions, because the idea is exactly the same, just we have polynomials now instead of numbers. So what's the answer to 3/5 plus 4/5? How many? 7/5. And how do you get that? You add the numerators. So this is what you did in your head. You did 3 plus 4, and you kept the common denominator. So we got 7/5. It's going to be the same exact idea with our polynomials. Now that's going to be an example from 7.3. The next one would be an example from 7.4. How about 2/3 minus 1/6? I need a common denominator. To add or subtract fractions, you have to have a common denominator. And that's where the problems for us get a little bit more difficult. So, Alicia, what's my common denominator you said? 6. So I'm going to write this, and I don't always write it vertically with our problems, but if I'm going to write this like I would in an 081 class. So my common denominator is 6. So what am I going to multiply this first fraction by? Not quite. Well, if I multiply it by 2, I'm going to get 4/3. 2/2. So I know what you're all saying, but the reason I make a big deal about it is it does matter. So you all recognize that 3 times 2 gets me to my common denominator, but what you're really doing is multiplying by what we call a form of 1. Where you have the same in the numerator and the same in the denominator. That's the only way we don't change the value of the fraction. 4/6 is just the scaled version of 2/3 because we multiplied by a form of 1. When you're dealing with expressions, you've got to multiply by 1s or you change their value. And the bottom fraction already has the common denominator, so I don't need to worry about it. So I now have 4/6 minus 1/6. So what's my answer? So I get 3/6, and then the answer from there, I have to simplify. Now simplifying for us goes back to what we just finished in 7.1, where at the end of one of these problems, you're going to have to factor cancel. So what we just did with simplify is the end of these longer problems. So the long process is common denominator, multiply by a form of 1, add or subtract the numerators, simplify. Just gets a little bit longer when we're dealing with polynomials instead of numbers. So today what we're actually going to do is add rational expressions and subtract them, and start with a common denominator. And you have one definition here. Equivalent fractions. To create an equivalent fraction, multiply the numerator and denominator by the same term or factor, a form of 1. So make sure when we get to Friday's class, if you need to get a common denominator, you always use a form of 1 here. Same numerator, same denominator. That's our 2/2. So these are your steps for adding and subtracting fractions, which we just went through with that example. If you want to read them out, they're there. And then our problems. Add or subtract as indicated. Simplify the results if possible. So when you're adding and subtracting, the first thing to always make sure is that you have a common denominator, which today, that 7.3 has common denominators. So if I look at A, x over 6 plus 7x over 6, common denominator, what part of fractions do I actually add or subtract? Numerators. So what I'm really doing here is I'm taking x and I'm adding to it 7x and I'm keeping it over my common denominator. Just like with the numerical example, the only part you touch is the numerators. They should have a common denominator. You keep that. And then you simplify the numerator if you can. So x plus 7x is 8x over 6. And you could certainly skip that middle step there, writing that out. And now we've got to go back to 7.1 and see if we can simplify our answer. Put a question mark, because you can't always. Can I simplify 8x over 6? I can divide them both by 2. So these are monomials, which means I can just look for a common factor to each term. With monomials, you're just looking for a common factor to each term. So I can divide both 8 and 6 by 2. So I get 4x over 3. So when you have monomials, you're just looking to divide out of GCF. When you have polynomials, that's when we have to factor cancel for that simplify step. So you've got to know how to add fractions and how to simplify from 7.1. B, a little bit bigger here. Want to add 2x plus 4 over 3x minus 1 plus 8 minus x over 3x minus 1. The only part you ever actually add or subtract are the numerators. These already have a common denominator, so I could take numerators and add them together over 1 common denominator. Yeah. So on addition you don't, but on subtraction you do. So to be consistent, I'm just always going to use the parentheses. Yes, you do not necessarily need the parentheses for an addition problem. For subtraction you do. So to be consistent, I'll just put that. Now, we want to work on just adding together the numerator. If we have any like terms, and this goes back to the first day of class. So you see how everything in here just snowballs on itself. So this is back to 5.1. Adding two polynomials, well, when you add, there's nothing special. You're just looking for like terms between all three of these. So my like terms, 2x plus x gives me 3x. 4 minus 8 is a negative 4 over 3x minus 1. So after you combine your fractions, the question is, can I now simplify the whole answer? So we've got to go back to 7.1. Can I simplify 3x minus 4 over 3x minus 1? Got a couple of votes with head shakes. What do you think? Can I simplify that one or not? No. These are all terms. Can't be factored. If it's a polynomial and you can't factor it, it cannot be simplified. That's the easiest way to know you're done with these problems, because that's another place people have trouble with. Where do I stop? If you can't factor either part of your final answer, so I can't factor 3x minus 4, I can't factor 3x minus 1, that means I can't simplify it. If you can't factor it, you can't simplify it. It's the easy way to know you're done. Even if you can factor it, sometimes you still can't simplify it. But that's what you're always looking for with a final answer. Can I factor it? So see, we have x over x plus 3 minus 3 over x plus 3. So I want to, in this case, subtract. Now because these are each monomials, I'm not going to include parentheses. If they were anything more than one term, you would. So it's going to be the first numerator minus the second over my common denominator. So it's the first numerator minus the second numerator, which they're both monomials, so it's just x minus 3, over my common denominator. Now, in every other example, we then combined. So we wrote it as 1, and then we combined. But for this problem, there's nothing to combine in the numerator. So my last question then is, can I simplify? I can't combine, but can I simplify the whole problem here? Got to vote for yes. I got to vote for no. See another head shake, no. Kevin, what do you think? Can I simplify? Yes or no? You're going to go with no. Gary, yes or no? Why not? Can't simplify if they don't have the same sign. So whenever you go to simplify, we had that, let's just go back. And the reason here we go. This guy right here. Well, one's addition, one's subtraction, can't be simplified. So, means, and that's why this example's on here. People are going to try. But simplify this one, you actually can't, so that's your final answer. So when you go to simplify, you got to have the same signs, both addition and both subtraction. Order doesn't necessarily matter, but you got to start with the same sign. Questions so far? All right, D. X plus 4 over x plus 7 minus x minus 5 over x plus 7. So we want to subtract. You've got to be more careful with subtraction than with addition, just like in 5.1, because it's not just x minus x 4 minus 5. It's the first numerator minus the second numerator. This is where those parentheses really matter, over your common denominator. First numerator minus second numerator in its entirety. That's why you have to use those parentheses. So after I get my problem over a common denominator, then I want to combine my numerator. But because it's subtraction, what do I have to do? You got to distribute that negative sign to both terms of the second numerator. Now certainly you could do that back in the problem here. I'm going to set it up like this. So it's really x plus 4 minus x plus 5 all over x plus 7. So you've got to be really careful with those subtraction problems. If the second numerator is anything more than one term, use parentheses, distribute that negative. And now that we've taken care of the subtraction, we can combine like terms and then try to simplify the whole thing. So combining like terms, I have x minus x. Those are actually going to take each other out. And then 4 plus 5 is 9 over x plus 7. So we got them over one denominator. We combine like terms. And now my last question is always, I'm going to have to write it underneath, can I simplify this final answer? No. I can't even think of a way that you would try if you wanted to do it incorrectly on this one. So that one's pretty simple. For E, getting a little more complicated looking. Y squared plus 3y over our trinomial y squared plus y minus 12 minus y squared minus 12 over that same denominator. So if you have a common denominator, it is the easier type of addition-subtraction problem. The only part you add or subtract is the numerator. So first numerator minus second numerator, all over your common denominator. Another really common mistake in these problems is that people try to simplify the individual fractions before they combine them. You want to get down to one fraction before you do any simplifying. So don't try to factor to simplify back in the problem. Wait until you make it into one fraction to try to simplify anything. So we've got one fraction now. Next step is to combine the numerator. So one fraction, then combine the numerator. This one's subtraction, so we've got that extra step of distributing our negative. So I have y squared plus 3y minus y squared plus 12, still all over my common denominator. And we're still working with the numerator, combining the numerator. So I have a y squared minus y squared. They're going to cancel. And then 3y plus 12, those aren't like. So I have 3y plus 12 over y squared plus y minus 12. So we got one fraction, combine like terms. Last question. Can I simplify that answer? Before you simplify, what do you have to do? Factor. Before you simplify, you factor. Before you multiply, you factor. Before you divide, you factor. So when it's polynomials, to simplify, what we're really checking is, can we factor either part or both? So 3y plus 12, can I factor that? Yes, how can I factor that? What's 3? Greatest common factor. Just the greatest common factor there. I can factor out a 3, and that's going to leave me with y plus 4. GCF. For the numerator, GCF of 3. How about the denominator? Y squared plus y minus 12. If I'm looking to factor that, what am I going to try to do? AC method. And in this case, I could use my shortcut since A equals 1. So AC is negative 12 and B is 1. Looking for a pair that multiplies to negative 12, adds to 1. Hang on, wait. Negative 3, positive 4. So I have y minus 3, y plus 4. So is there anything I can cancel? The y plus 4, both in the numerator and denominator. So I end up with 3 over y minus 3. Can I cancel anything that's there? No, because now we're back to terms. Once you're out of factors, you can't simplify. So I told you these problems get a little bit longer. They'll get a little bit longer still on Friday, because they won't start with a common denominator. Then we gotta go through that mess. So any questions on the steps for adding, on the simplifying at the end? Okay. All right, F. 5x over x minus 1 minus 5 over x minus 1. Now it is a subtraction problem, but I don't have to be quite as careful because my numerators are monomials. The only time you absolutely really should put those parentheses is if this second numerator has more than one term. So I'm going to set up the first numerator minus the second. And the only reason I'm not using them parentheses is because I have monomials. And it's all over my common denominator. So first step, make one fraction. My second step was always combine my numerator. Can I combine anything in this numerator? No. So my last step is, can I simplify this at all? Yes, or I at least have the potential. What am I looking for when I'm talking about simplifying here? Factoring. I've got to be able to factor if I'm going to simplify, unless you have monomials. If you have monomials, you can just simplify within that fraction. But simplify, what I'm really looking for is, can I factor any part of that? So my numerator is the part of this fraction that I can factor. How am I going to factor that? Greatest common factors, 5, I heard, and then left over, x minus 1. And don't forget to write those GCFs out front. A few people on their test would factor out GCF and then just kind of was gone. You got to leave those GCFs out front. So is there anything I can simplify here? Ready, Napoleon? X minus 1. Remember, if you see a binomial that you can't factor, you're always welcome to put it in parentheses. So I have the same factor in the numerator and denominator. Now, do they cancel exactly, or do they leave me a negative 1? Exactly. So even though they're subtraction, they're identical factors. The only time you get the negative 1 is if they're subtraction and you got the switch in one of them. So those just cancel, so my answer is 5. Yeah. Yes, it would be positive 1. Yes. Yes, if you ended up with exactly the same numerator and denominator, your answer would be 1. Any other questions? Now, G is more what your problems are going to look like on Friday. G is a little bit more of what it's going to look like on Friday. Any ideas of where we might start? Denominator is the same. I have x plus 4, x plus 6. I could distribute. So I could take this times this times this. Where did we start all of our problems today? Make one fraction out of the numerators. So we could follow that same. Am I going to have enough room? Let me go down here. I could follow that same setup there. Now you may want to put. I'm always on the edge about how I show you guys this. That's really how I would write it, because in our other problems we talked about, right, the negative sign has to get distributed. But if I put it with the 6, what number am I distributing? Negative 6. So the negative's still working its way through that problem. So I'll show you this problem 2 ways. This is what I consider the easier way, the way of less writing. Is if it's a negative and this is a monomial, you can put it with the monomial you're going to distribute. I'll show you this 2 different ways. All over my common denominator. So we made one fraction. What was our second step? We're going to have to distribute to combine the numerators. So I'm going to have to distribute the 2. So we're looking at 2x plus 6. And then I'm going to distribute a negative 6. So it still takes care of distributing the negative. It's just going with the 6. We're just going to give me negative 6x plus 24 all over x plus 4, x plus 6. What do I want to try to do next? I'm not going to factor it quite yet. Combine. Make sure that numerator is as combined as possible before you kick into factoring. So I can combine my x's and I can combine my numbers. So I'm looking at negative 4x plus 30 over x plus 4, x plus 6. And now that the numerators combined, my last question is always, can I simplify? Yes. And I can simplify because I can factor. I can factor the numerator. How am I going to factor that numerator, negative 4x plus 30? Yeah. Negative 2. Why would you factor out a negative 2 and not just a 2? The first term is a negative. So you're going to find this, and I know there's a problem somewhere that you do in your homework. When your polynomial starts with a negative term and you have a GCF, we talked about factoring out a negative GCF. So I'm going to factor out a negative 2. And just be careful when you're factoring out negatives because they do change both the signs. So now I have a positive 2x minus 15 over x plus 4, x plus 6. So I factored, that's part of my simplify step, but did anything cancel? No. Bummer. Extra work that didn't end up getting us anywhere. It happens. So either one of these answers would be acceptable, but you really have to go to the factors to see if it simplifies. If you stop here, you're going to lose points on some problems because when you factor, you could cancel. So it would be like on, I'll bring that back down in a second. It'd be like here, if you stopped here, you didn't try to simplify, you'll lose points. So that's most of that problem, actually. But here, unfortunately, it didn't help you out. So your other option on this problem is to start by multiplying out your numerators. So if you start with your distribute, we have 2x plus 6, and then 6x minus 24. And let me put this in blue. So if you start out by distributing, then it will look like our other problems where you take the first numerator. So in blue here is just another option, minus the entire second numerator. All over x plus 4, x plus 6. And then when you went and distributed the negative 1, you're actually going to end up at this same exact step right here. So you can either distribute this as a negative 6, and that takes care of both your distributing and your negative sign kind of all wrapped into one step. Or if you just distribute the 6, you need the parentheses to then go back and distribute the negative sign. But they're both going to get you down to this step right here. It's up to you which way you like better. Questions? Again, you got to be really solid on this part, so when it comes Friday and we add 2 more things in front of it, it's not too bad. All right, so we still have good time. Excellent. So I've got 2 problems for you. Let me... So your directions are add or subtract as indicated. And first one is x plus 4 over 9. 2x minus 25 over 9. And the second one and the second one, 2x plus. All right, go ahead and try those 2 problems.